That's the coolest thing ever.
This is a perfectly good radio, and this is a perfectly good AM radio tower. One very much designed to be handheld and receive power. The other designed to radiate so much power that if you were to touch it, well, in the tower's own words,
I will greatly multiply your pain.
in fact, you'd turn into a plasma barbecue while screaming the radio broadcast.
Thank you so much, John. Appreciate you, man.
Worst of all, you wouldn't even taste good. Now, that radio tower doesn't have a speaker, so where's the audio coming from? Well, it has a little bit to do with plasma, and how the radio plays through the plasma is a part of a fascinating story. Modern radio towers are an engineering marvel. Pumping out controlled radio signals hundreds of miles away, they can transmit a lot of power. And just how much power are we talking? Well, this is a 7 kilowatt tower, part of a 12 kilowatt system. And the strongest in the world can exceed 2 megawatts. That's 2 million watts of power to be used for not just telecommunications, but also wireless power. However, not all radio towers are created equal. FM radio towers tend to be taller and have their antennas at the actual top, seen here in the Schokel transmitter because FM works by line of sight. These towers will also be grounded for lightning protection. AM radio, on the other hand, uses the actual tower as the antenna, and as such, their height corresponds to the transmitting frequency. Since the antenna is charged to several thousand volts, this means touching the tower can be seriously dangerous, something Jeff from Geerling Engineering knows a thing or two about. You might have seen a video from earlier this year where Jeff and his father electrically ground a hot dog, touch it to a tower, and make an incredible plasma speaker. Well, I heard that speaker 2,000 miles away, and after they invited me to visit the same 12 kilowatt transmitter site, I got my ass on a plane and brought a little surprise because I had a date with wireless power. This video is sponsored by Ground News. Okay, the vaporized hot dog video amazed me, hands down, but it also reminded me of the basics, that radio isn't just some mystical, invisible communication form. It is radiated electrical power in a form that travels incredibly far. Being born into the digital era, cell phones are a permanent fixture of our daily lives. Despite completely changing the future of humanity, we are numb to the miracle of radio transmission. Most of us simply know it for the music in our cars or for long-distance communication. That's the small-scale stuff, but what radio actually is on the producing end, it's a scientific miracle on its own. Imagine, if you will, there exists an alien planet, and on that planet is a power-intensive species, using electrical power for their entire civilization. But upon closer inspection, there aren't any power lines. No wires, just these mysterious white beacons which radiate power invisibly out into the air. And hundreds of miles from a tower, an individual of their species can draw energy out of the air for their daily needs. One single tower covering tens of thousands of square miles. That would be amazing. Oh wait, that's us! Radio towers are beacons which radiate gargantuan amounts of high voltage power in the form of radio waves. Though energy delivery drops off at an exponential rate with distance, at their very essence, they're a method of wireless power transmission. But how does that power act differently from what's flowing through power lines? And how would you extract electrical energy out of the emitted radio field at a distance? Enter Geerling Engineering. After a quick chat with Jeff, he invited me out to a tour site in Missouri to answer these questions. So I geared up for a journey, browsed possible flights, and started building a wireless energy receiver because I was headed to the arched city known as St. Louis. After a short journey and 2 colic babies, I arrived at the transmitting station and my little tum-tum exploded with little plasma butterflies. Jeff, the man. How you doing? After a short chat, we took a walk through the transmitting room where Jeff shared a bit about audio processing.
It sends it over here. This is in the old days they'd have like an exciter and a whole rack of equipment, but this now does everything. It processes the signal and sends it into the transmitter. For ham radio guys, you'll see numbers that you'll be interested in. My dad mentioned the reflected power on here, 40 watts coming back from the tower is actually not that good, and usually it's better tuned.
Okay.
But as time goes on and there's moisture and animals and stuff, that you need to retune it. but right now it's putting out 12 kilowatts, just a hair over it, I guess.
And this is the tri-tower system is doing 12 kilowatts,
yeah,
correct?
so this is one feed from the transmitter. This sends out a signal you can see from the top. Signal comes out, don't touch any of this stuff because you'll die.
Looks like I was in the right place. Anyways, after the signal travels through this cable, it lands in a separate compartment filled with various oscillators and massive radio frequency capacitors. Surprisingly, these components don't get too hot, but it's interesting to see where the current is flowing in this IR shot. This, though, is next level. Do you guys hear that right now? There's no speaker in here. That is purely the RF being transmitted through, presumably the vibration of the wires, expansion and contraction of the capacitors and inductors. Ultimately, they tune the transmitter output and match impedance with the towers, creating an efficient transmission at 1.46 megahertz.
You'll have someone who's lived their whole life a devout Catholic.
You can see the actual...
Oh, spectacular. Yeah, there's the amplitude modification.
You can see the amplitude instead of the frequency.
Yeah. With an output power of 16 amps at 800 volts, it was pretty impressive. And the high frequencies meant, yeah. As I was enamored with all the amazing radio equipment, I failed to notice there was a terrorist amongst us. You see, there have only been 3 times in my life when I stared death in the face, and this time I showed not an ounce of fear. Ah, it's pissed! Oh, shoot.
That'd be fun.
Go up there. Go where you belong, Wasp.
He's getting his buddies.
It could be anywhere right now. Anyways, after defeating Satan, we headed out to the tower, which seemed totally safe. We have legal access to this radio tower, right?
Yes.
Excellent.
Yes. I've been deputized.
Deputized? Okay. I would like to be the deputy of high voltage. That'd be great. Yeah.
So far, we haven't had a camera get killed by the RF.
Hey, Jeff, what are those black marks right there on the tower? Looks like something got cooked there.
I don't know. I think that the engineering staff is going to have to investigate what is happening to this tower. Because usually towers don't have char marks on it like that.
Yeah, what are those char marks from?
Base. And the ring comes out. There's a catch.
Being nearly 50 meters tall, towers of this style require guy wires, and they are fenced off for good reason. Probably so I don't get to them. I'm fine.
Yeah, no, the Jurassic Parkway.
The dress. And then we both die. Now, since we had access to a commercial radio tower, I wanted to start visualizing the energy output of that transmitter and what effect our experiments might have on transmitting strength. The central antenna was at about 8 kilowatts of power, and couple that with radio frequencies, whew. We set up cameras on both the transmitting station's output ammeter as well as a field strength meter over 30 kilometers away a city over. With that, our lunchtime soiree was ready because the Geerling squad brought the entire kitchen. Corn dogs, pickles, sausages, items which love to conduct electricity. To make sure we don't conduct electricity, these high voltage gloves did the trick.
Hopefully we won't find out.
After attaching a connection to electrical ground and donning the most impressive culinary gloves, destiny was right around the corner. First, I'd like to emphasize, don't do this yourself. I have 22 years of high voltage experience. Joe is a radio vet, and Jeff also has his certification. I mean, take it from Joe.
Don't even mess with AM towers at all. Don't even mess with towers. Like, people who haven't learned about towers have no business on them. You really got to be careful. I say that as a guy who's seen like the remains of a guy. It's when you blast from a tower, not good, not good. It's not good. We got these gloves which are almost infinity voltage, and I'm staying my distance. We calculated, and I got the nice wood stick, holding that out like this. Got my safety glasses on that I like.
There you go. We do this for educational purposes, and all warnings aside, fanboy activated, man.
Is that gonna stay on there? Oh man, it's floppy.
First of all, remember he's a Roman citizen. That's why he wasn't crucified when he was killed. He was beheaded. Because says that women call the
coolest thing ever.
Yuck.
Just so you know, my shotgun mic didn't really capture how insanely loud that plasma was. I mean, it hurt your ears to be that close. Now, considering their salt content is through the roof, we were curious how a pickle would fare up against RF plasma.
in the temple. Mary says, son.
Surprisingly, the pickle performed worse, but that's likely due to the fact that it was too conductive, bogging down the transmitter, dropping from 16 amps down to less than 9 at times. However, in reviewing the footage, we captured something incredible. The initial contact created a plasma shock wave. Awesome.
This is, I don't know if this is a good idea.
You know, I don't know if a fried pickle's good in the first place, but... I can still taste that pickle. When it comes to smoke and visual effect, though, nothing beats a corn dog.
Will this insulating layer of corn protect the hot dog?
Yeah, let's see.
Let's do it this way.
This is the cooking them up.
Back at this time, and always listen to your broadcast. I love it. The show is beautiful. Thank you so much, John. Appreciate you, man. And then Anthony, also on YouTube.
Check this out. Ammeter dropped from 17 down to 11 amps.
Always listen to your broadcast. I love it.
And the field meter shows a corresponding 50% drop in received voltage at 30 kilometer distance.
From work at this time, and always listen to your broadcast. I love it. The show is beautiful.
Our experiments and use of food as literal plasma speakers was causing an immediate and measurable drop in transmitted energy to nearby cities. We were taking energy out of the system, and therein lies a hint to how audio was playing through the plasma. Consider this. An electrical arc from a neon sign transformer in the US sounds like this. A 60 hertz hum. But why? Why that tone? Because the electricity feeding the transformer from the wall is 60 hertz AC. So the high voltage arc is a plasma channel growing and shrinking 60 times a second due to fluctuating power. This causes pressure waves that our ears hear as a 60 hertz hum. What if the frequency feeding the transformer varies? Well, then the audible pitch to our ears will vary. A prime example of this is a portable plasma speaker circuit I recently built. It uses an audio signal to turn on and off a high voltage transformer at the frequency of the audio. So the sparks it produces... Oh, that's amazing. Match the frequency of the incoming audio, creating a plasma speaker. Now, the plasma speaker created at our tower site works in a similar manner. This site transmits AM radio using amplitude modulation. You can see the signal strength for the station's 1.46 megahertz signal varying in this live feed. And what causes the signal strength to vary? Audio input. AM radio overlays two signals of electricity, first being a dedicated transmit frequency, second an audio input that has peaks and spikes in our audible range. This results in a silent carrier wave carrying audio information we can hear. Zoomed out, you can see the station's signal carries this audio distortion, corresponding to momentary distortions in power. Considering kilowatts of power are being modulated and the tower conducts this power, a grounded object that comes into contact with it will act as a pathway to ground, causing a massive power dump. This vaporizes our sausage, and the surrounding air turns into conductive plasma. And remember that plasma channels can grow and shrink with added current? Well, faster than our eyes can see, the plasma channel expands, contracts, at the audible frequency of the radio station, leading to a plasma speaker we can all hear.
I will greatly multiply your pain. You shall bring forth.
Apparently, it'll also greatly multiply your pain. Now, AM radio is primarily used for talk radio and news. Depending on the station and broadcaster, the news may be presented with a bias or not even reported at all. Just as with any news source, this makes it virtually impossible to tell which news stories are based in reality. I think you know what I'm talking about. And that's where ground news shines as a beacon. They gather news articles from over 50,000 sources globally and analyze the sources for bias, so that you can compare coverage and see if the story is reported on one side of the political spectrum, both or neither, plus just how factual it is. For example, if you haven't heard, 2 American astronauts are stranded in space right now, after Boeing botched a return mission on the Starliner. Taking a look at the coverage details, you can see this story was covered by 100 left-leaning news sources, 47 right-leaning, and 139 central. Clicking on bias distribution shows this story was picked up across the spectrum, and to see how each side reported, you can select left-leaning viewpoints, right-leaning viewpoints, or view a bias comparison between the two. For this news article, the left frames it as a reflection of Boeing's values of safety, while the right frames this as another dangerous incident due to bigger issues within the company. Ground News also has a blind spot feature, which indicates stories which are disproportionately covered by one side of the political spectrum, or not at all. Created by a former NASA engineer, their goal is to give readers an objective, data-driven way to stay informed. By collecting data on a news source's political bias, credibility, and ownership, Ground News gives you the power to see through the sea of screaming voices to learn the real facts. I really like the idea of ground news because it gives the power back to the reader to determine what type of bias is being shoved in their face, what type of narrative is being shoved down their throat. I mean, I should probably say, oh, I've been using ground news for years. To be honest, I had never heard of ground news, but this will be the only news source I use going forward. It's awesome. Scan the QR code on screen or check them out at ground.news/plasma to subscribe today. You'll get 40% off the same Vantage plan I use for unlimited access. Okay, back to the field. It's seriously awe-inspiring just how much power is pumping through these radio towers. And keep in mind, this power is designed to be radiated wirelessly through the air. So, next, I want to see just how far from the tower we can be and still extract energy out of the thin air. And I've built a special circuit which helps me do just that. It was a pretty simple build which I did back at the shop. Busting out the RF receiver, I was anxious to see it extract power, but quickly realized we had a problem. It was impossible to see the LED in sunlight, so we walked closer and even closer. But the LED never lit, which was a complete mystery to me because surely within 30 meters of a 12,000 watt transmitting station, you could light up an LED, right? So we brought it inside to do a few measurements. We inspected the antenna for breaks, which was intact at 32 ohms, and the capacitors worked, yet the system was only outputting 1 millivolt. Damn. This told us the radio frequency diodes had blown. But why? Blown diodes indicates too much power. The plot thickens. Taking the receiver back to Jeff's shop, we replaced the diodes. Doing a quick transmission test with a 5-watt radio, the system worked perfectly. There we go. Sending a sustained transmission with the circuit permanently turned on, and the LED gets brighter with proximity. Absolutely amazing, and working as intended. This got us thinking, what if that LED wasn't in place? What voltages would build up? We're just going to test the voltage output of this receiving circuit. So here we go. Starting at a couple millivolts, and then
You ready?
5-second transmission. And now I push the power button, and it says 14.3 volts charged. It works! Considering we transmitted at 144 megahertz and my antenna resonates at 1.68, they were far off from tuned. Okay, so the receiving circuit produced 14 volts while being completely out of tune with the transmitting signal, a signal that only lasted a couple of seconds at a power level of 5 watts. Imagine if this circuit was in permanent proximity to, I don't know, like a 12 kilowatt system that nearly perfectly matched the receiving frequency. Yeah, we'd be seeing way more voltage than that. I don't know, maybe enough to blow a diode? After chatting with Joe, we concluded the receiver likely blew itself when I was still kilometers from the tower. So by the time I drove to the site and pulled it out of my car, only 30 meters from the tower, it was dead. Armed with this knowledge, we visited the tower one last time. We wanted real readings, and this time, I didn't attach the antenna until the camera was rolling.
4, 5. No, we're going up. 6.
Okay, so
okay, we're gonna pop it soon.
Removing the antenna stopped all charging and potentially saved the circuit. Watching the voltage drop this quickly indicates it could benefit from larger caps. Reattaching the antenna. Yeah, charging faster this time, a lot faster.
Yep.
Fast enough that after a few seconds of charging, it built up enough power to flash the LED.
Yep.
Little pulsaroni.
Yep.
It broke shortly afterwards, but honestly, I've never been happier for a project to break because it indicates that it was doing its job. It was actually pulling too much power out of the air and blowing itself up. So I really want to build a more powerful, more robust version of this generator. Let me know in the comments if you'd like to see a video about that. Also, don't forget to check out Geerling Engineering's channel for their video about my visit. It'll be a different take entirely. Now, don't let the ferocity of a blinking LED overshadow how cool the musical plasma is, because they're both a part of the same story. One of the greatest stories ever told, wireless power transmission, aka radio. So, next time you drive past a radio tower, just remember what they really are. They're beacons of wireless energy. Think about that. Thanks for watching, and you stay classy.